Hey guys, so in this video I'm going over the Pythagorean theorem word problems. So we're going to be using this as we go into Unit 6, which is our trig unit. So what do I mean by the Pythagorean theorem? I mean if you have a right triangle, so it doesn't matter how perfect it looks as long as it has a right angle somewhere in it. The side across from it is going to be your hypotenuse, and that's going to be represented as C. Now the other two sides of the triangle, if it's a right triangle, are going to be its legs. So it doesn't matter if you call this one A or the other one A, or you call this one at the bottom B or the other one B, does not matter. So the other option, let's say it looked like this. Facing the other way, there is still a right angle. The side across from the right angle is always your C. Let's say the bottom one we labeled A, and the one vertical is our B. Doesn't matter, A and B are your legs. And how we're going to find these missing sides, because we're going to be given two of the three and asked to find the other, is our A squared plus B squared equals C squared. So let's look at some of these word problems where we are going to have to set up our triangle and then use our theorem to find the missing side. So in the first problem, the slide at the playground has a height of 6 feet. The base of the slide measured on the ground is 8 feet. What is the length of the sliding board? So we have the place where the slide is against, and it's going to go to the ground. Now, whatever it is leaning against, we can assume that it's going to create a right angle with the ground. And then the slide is going to come right there to the ground. Now, the slide is 6 feet, so 6 feet from the ground. And then measured on the ground is 8 feet. So the slide on the ground is 8 feet, so that means from the beginning of the slide to the end of the slide on the ground is 8 feet. And we are asked, what is the length of the sliding board? So what is this measurement? So kind of like what we talked about when we were going over what the theorem is. The side across from the right angle is our hypotenuse, so that's going to be our C. And then our other two sides of our triangle is our legs, so it's either A or B, whichever one you prefer. So what we're going to do is we're going to write our, don't want to start with that. I'm going to start with our A, so 6 squared, plus our B, which is 8 squared, equals our C, which is x squared. And then we're going to solve. So our 6 squared plus our 8 squared gives us 100. And then we can't do anything with the x squared yet. Once our x squared, or our thing squared, is by itself, then we can handle our square. We're going to take the square root of both sides. This gives us 10, and this gives us just x. And that is our answer for number 1. So let's do number 2. Number 2, the bottom of a 13-foot straight ladder is set into the ground 5 feet away from a wall. So first let's draw our wall. Typically anything in nature is going to create a right angle with the ground, unless it's leaning against something, but a wall is not going to be leaning against anything. Something may be leaning against the wall, but not the wall itself. So the wall is going to create a right angle with the ground. And then we have a 13-foot straight ladder, and it is setting against this wall. So here is our ladder. I know I'm not a perfect drawer, but here is our straight ladder. That word straight is just meaning that there's no curves in it. And it is 13 feet. And it is setting into the ground 5 feet away from the wall. And then we are asked, what is the distance of when the top of the ladder is leaned against the wall? What is it the distance above the ground it will reach? So we're asked, what is this distance? Well, we have our side across from our right angle, our hypotenuse. So we have 13 as our C. And then we have our two sides, or two legs, our A and our B. So let's start with our A. We have x squared plus b squared equals our c squared, which is 13. And then we're solving. So let's go ahead and do, can't simplify x squared yet, but we can simplify 5 squared, which is 25, equals 13 squared is 169. Then we're going to get x squared by itself, so we can deal with that squared. We're going to subtract 25 from both sides. Let me change that color. Subtract 25, subtract 25. We get x squared equals 144. We're going to square root both sides to get x by itself. To get rid of that square, we get x equals 12. And that is our answer for the height where the ladder is going to hit the wall. Alright, number 3. Number 3 is a little bit difficult. So, you can read it. Basically, in shop class, you're going to create a table, and it's going to be a rectangle. So, rectangle with the dimensions of 36 inches by 18. And we're being asked about the diagonal, so that's going to be from the top corner to the bottom corner. And it doesn't matter if you went from the top left corner to the bottom right corner, as long as it's the diagonal. So then you're asked, is this table square? And what it means by square is, do we have right angles? Well, if this is a right angle, and we already have two of the sides, which is the 36 and the 18. So we're looking at this triangle here. That means if we use our theorem, we should have, according to this, we should have 43 here. And that would make this table square in terms of construction class. Well, we need to check. Let's see if we truly get 43 if we use the theorem to find our hypotenuse, or our C. So let's put an x there, and let's solve to see if that gives us 43. So we have our hypotenuse, we have our two legs, and that's A, that's B. We'll have 18 squared plus 36 squared equals x squared. We simplify, 18 squared plus 36 squared gives us 1,620 equals our x squared. Solving for x, we take the square root, and we get approximately 40.249 approximately for our x. So do we get 43 as our diagonal? No. So 40.2 does not equal 43. So the answer is no. This table with a diagonal of 43 is not square. So that means if we were given dimensions of 36 by 18, and we were also told that diagonal is 43, that means all of the angles are not right angles. Or the corners of the table are not all right angles. So it's a weird looking table. Alright, pause the video. Attempt number 4. Okay, you should have gotten this for number 4. So the answer should have been 14.42. So with my green, so you have this cloth that you're going to drape over a clothesline that's going to go that way, and then some wires that are going to connect it to the ground. So that's your cloth right there. And you're told that the height is 6 feet. And the opening into this little hut is 8 feet. Well, that means that this is 4 and this is 4. So that's where I'm getting this triangle over here for. I'm only looking at half of this opening. So then I solved for my hypotenuse to find that the length of one side of this cloth at the top of the hut is 7.21. So that means the other side, because it said it made an isosceles triangle, that means the other side is 7.21. So I added those together to get my answer of 14.42. Alright, let's look at another one, number 5. So a baseball diamond is actually a square with sides of 90 feet. So I'm going to take this sentence by sentence. So I'm going to have a perfect square that is tilted like a diamond. And it's a square, so all of the angles are 90 degrees. It's also a square, so I know that each side is the same. So we have home plate, or home base. We have first base, second base, and third base. Then we go into, if a runner tries to steal second base, how far must the catcher at home plate throw to get the runner out? So we're asked from home base or home plate, how far does the ball have to travel to second base? So that's what we're looking at. Given this information, once we find this out, explain why runners more often try to steal second base than third. So we're going to look at this triangle here. So this was second base, and first base, and home plate or home base. And we want this. This was a right angle, this was 90, and this was 90. Okay. I don't know why my iPad just did that. There we go. Okay. So we've got our triangle. We want this distance from our second to our home base. And we know that second to first is 90. Our home plate to first is 90. And we're solving, and this is 90 degrees, so we can use our theorem. There we go. So hypotenuse is x. So our legs, our A and our B, is 90. So we have 90 squared plus 90 squared equals x squared. Our 90 squared plus 90 squared gives us 16,200 equals x squared. We're going to take the square root of both sides to get x by itself, and we get x is 127.28. So the question is, given, let's say we're a runner on first base, why is it that a runner typically runs or steals second base while the catcher is having to throw it 127.28 feet versus a runner trying to steal third, which is running 90 feet, while the catcher is only having to throw it 90 feet. Hopefully you can see it written out. The answer should be runner only has to run 90 feet between first and second base while the ball has to travel approximately 127 feet. So that is why mathematically baseball and softball steal second base versus third more often. Okay. Number 6. So your family wants to purchase a new laptop with a 17-inch screen. Since the 17 inches, it represents the diagonal measurement of the screen, upper corner to lower corner. You want to find out the actual dimensions of the laptop. So we're dealing with the rectangle. You've got all 90-degree angles are right angles. Talking about diagonal of 17. When you measured the laptop at the store, the height was 10 inches, but you don't remember the length, or the width, so we don't know this one. Calculate and describe how you could figure out the width of the laptop to the nearest 10th inch. So the triangle we're looking at, or the right triangle we're looking at, is here. So the diagonal was 17. We've got 10 as our height, and we want to know the width. So we have our hypotenuse, we have our two legs, so let's solve for that missing leg. We've got 10 squared plus x squared equals 17 squared. We can simplify the squares, so we've got 100 plus x squared equals 289. We're going to subtract 100 from both sides to get the x squared by itself. And we're going to get 189. Once we get here, we can get the x by itself by square rooting it to get rid of the square. And we get x is approximately 13.7. And that is our answer for number 6. All right, pause your video and attempt number 7. You should have gotten for number 7, 44.7. So I went on ahead and wrote which side was meaning what. So Deshaun was starting here and ran 40 feet, I think it was, 40 yards, and then turned. So that is his 40 yards. Michael started 20 yards away from where Deshaun started and ran a diagonal to block him. So that is how long Michael's run was, and that's what you're finding, which should have been 44.7. Alright, make sure if you have any questions, please don't hesitate to contact me. I will probably have another Zoom meeting Wednesday. Thanks.